All right, let's jump right in. Today, we're taking on one of the biggest questions you can even ask. What is reality really? We're going to explore what's called a theory of everything. But it's not just about physics. It's about how everything, our universe, our knowledge, our very ability to understand, weaves together into one single coherent story.
And to get us started, I love this thought from the physicist John Archibald Wheeler. He had this dream of finding an idea so fundamentally simple, so beautiful, that once we saw it, everything would just click. We'd look at each other and say, of course, how could it have been any other way? And that's really what we're digging into here.
Okay, so Section 1, a universe of knowledge. Our journey starts with a really basic puzzle. How do we know all the stuff we know?
I mean, just think about this. We know for a fact that a gamma-ray burst happened 7.5 billion light-years away. That's more than halfway across the known universe. How is that even possible? We weren't there. We can't go there. So how can we know anything about something so unbelievably far away?
Well, the answer isn't about just collecting more and more facts. True understanding, real knowledge, it comes from something way more powerful. It turns out, a single good explanation can cover a potentially infinite number of individual facts. So the key isn't just what we know, it's all about how good our explanations are.
So how do we get to those good explanations? This leads us to a really common idea about how science works. An idea that feels right, feels like common sense, but is actually a total myth. And we kind of have to tear it down before we can build up the right idea.
This myth has a name. It's called inductivism. It's the idea that we learn by just looking around, noticing patterns, and then assuming those patterns will continue. You know, you see the sun rise every single day of your life, so you generalize, hey, the sun's going to rise tomorrow. Seems logical, right? But it's got a fatal flaw.
And here's the flaw. The future isn't always like the past. Prediction is useful, sure, but it's not the main goal of science. Explanation is. For thousands of years, all people ever experienced was falling. Based on past experience, flight was impossible. But once we got a good explanation for aerodynamics, we didn't just predict the future, we created a new one. We built airplanes and we flew. Good explanations let you build things that have never existed before. There's this fantastic, if a little dark, analogy from Bertrand Russell about the inductivist chicken. See, every single day, the farmer comes out and feeds the chicken. So from the chicken's point of view, it's theory that the farmer is my friend who brings food gets stronger and stronger every day. The evidence is overwhelming, and this theory works perfectly, right up until the day the farmer comes out and wrings its neck for dinner. The punchline here is just brilliant. The disappointment of trillions of chickens is itself inductive proof that induction doesn't work. So if just observing patterns is out, what's in? Well, the answer is beautifully simple, but it changes everything. It's the power of a good explanation.
To really get this, let's put two different ways of explaining the seasons side by side. On the left, you've got the ancient Greek myth. Persephone gets dragged to the underworld. This makes her mom, Demeter, the goddess of the harvest, super sad, and her sadness makes it cold. That's winter. Okay. On the right, you have the scientific explanation. The Earth is tilted on its axis.
Now, what actually makes one of these a good explanation and the other one a bad one? Here's the crucial difference. The Persephone myth is easy to vary. Think about it. You could say it was a different god, or that Demeter was angry instead of sad, or that it was for 9 months instead of 6. The story still kind of works. The details are arbitrary. But the scientific explanation, that one is hard to vary. You can't just change the angle of the tilt, or the laws of how sunlight carries heat, or the rules of geometry, without the whole explanation completely falling apart. Every single detail is locked in place by other parts of reality.
And that, right there, is the key. That's the big takeaway. A good explanation is hard to vary. Its pieces are so interconnected, so tightly woven together with what it's trying to explain, that if you try to change one little detail, the whole thing just unravels. That's the test. That's how you know an idea is really grabbing on to a piece of reality. Okay, so this one idea, this hunt for hard-to-vary explanations, it turns out to be the master thread. It's what allows us to weave together our deepest theories into this single, coherent fabric of reality. It connects 4 huge areas of knowledge. So the physicist David Deutsch, who's really the architect of this whole framework, he argues that our deepest understanding of the world rests on these 4 pillars.
You've got quantum physics, the rules of the very small, epistemology, which is the theory of how we create knowledge itself, the theory of computation, what's possible for computers to do, and the theory of evolution, which explains how knowledge, in the form of DNA, gets created in biology. Each one is powerful, but woven together, that's when you get a theory of everything.
Now let's take a concept that sounds like pure science fiction, right? The multiverse. It's not just some cool idea from a movie, it's currently the hardest to vary explanation we have for what we see in quantum experiments. To explain why a single particle can interact with itself, we have to propose that there are countless shadow particles in other universes that it's interacting with. It sounds bizarre, I know. But if you take the multiverse out of the equation, our explanation for what we physically observe in the lab, it collapses.
And this isn't just philosophy. The consequences are absolutely staggering. A future quantum computer, for instance, isn't just going to be a bit faster. It's expected to solve problems that are impossible today by tapping into the processing power of other universes. How much power? Well, the number of parallel computations is estimated to be something like this: 10 to the power of 500. That's a 1 with 500 zeros after it. You can't even write that down properly. That's not just a big number, that is the physical reality we're talking about.
So where does this leave us? This unified view of reality, built on the power of explanation, leads to a final, profound, and I think, deeply optimistic conclusion about who we are and what our future holds.
If you accept this way of thinking, it leaves you to a statement that sounds kind of crazy at first. All evils are caused by insufficient knowledge. Now, that's not just a nice, hopeful thought, it's a direct logical consequence. If the only thing holding us back from solving a problem is finding the right explanation, then things like poverty, disease, and suffering aren't fundamental features of the universe. They're just problems for which we haven't yet found the solution.
And that boils down to 3 simple but world-changing words. Problems are solvable. Every problem, whether it's curing aging, or developing clean energy, or traveling to the stars. The only thing in our way is our current ignorance. The only limit is our ability to create new explanatory knowledge. Our potential for progress isn't just big, it's infinite. So this whole idea, it just completely flips the script. We're not some insignificant accident in a meaningless cosmos. We are the universe's way of understanding itself. We are universal knowledge creators. And if that's true, then the ultimate question isn't if we can solve our problems. It's a choice. The real question is, what will we explain next?